So we'll end the section here by examining a special limit. Limit as x goes to 0, 1 plus x to the 1 over x power. And we want to show that that's actually e, which is kind of interesting, because you think about this, as x goes to 0, this base approaches 1, and then the exponent looks like 1 over 0. And depending if your x is positive or negative, this is going to be infinity or negative infinity. So this is limit has the form 1 to the infinity or 1 to the negative infinity. And if you think about it, either one of these limits, they have two opposing things that are going on. The base is approaching 1, and 1 to any power is 1. However, if x is positive, this is a little bit bigger than 1, and the exponent's going to infinity. You take a number bigger than 1 and keep raising powers on it, it goes off to infinity. If x is less than 0, then that number is a little bit less than 1, and then this will approach negative infinity. So a number that's less than 1, and it's going to a big negative power. Well, if it's a big positive power, it would approach 0. A big negative power, again, it's looking like 1 over 0, which is infinite. So something kind of crazy is going on here. We want to figure out, how does that end up being the number e? Well, recall here that if f of x is the natural log of x, then f prime of x is equal to 1 over x. And so f prime at 1 will be 1 over 1, which is just 1. But also, by the definition of the derivative, f prime at 1, that's definition of derivative at a point, is equal to the limit as h goes to 0, f at 1 plus h minus f at 1, and divide by h. Now again, what I'm doing here is I'm using the f prime at a. Our limit definition there was, this is the limit as h goes to 0, f at a plus h minus f at a, and then divide by h. So that's what I'm doing with a equals 1, and our function is the log function, ln of x. So this is going to be limit h goes to 0, and this will be natural log, so ln of 1 plus h minus ln of 1, and then divide by h. Well, log of 1 here is 0, so that drops out. So this is really just limit h goes to 0, ln 1 plus h over h. I'm going to write that as 1 over h times the natural log of 1 plus h. And remember, numbers out in front, we can take them and put them up as an exponent, inside exponent over that expression, because they factor down, they factor back up also. So this is actually the limit as h goes to 0, and this will be natural log 1 plus h, and then it'll be 1 over h power. Okay, and then, well, that's the same if we change this h to an x, just change the name of the variable. That's the same as limit x goes to 0, ln of 1 plus x to the 1 over x power. And what we know is that that's got to be 1, because we know what the derivative function is for natural log. So we'll look at this right here. That's this right here. That's the limit that we want to show is e. And what do we know? Well, we know the log of that is 1. So what's going on here is that the natural log of the quantity 1 plus x to the 1 over x power is approaching 1. So if we exponentiate on both sides, then e to the ln 1 plus x to the 1 over x power should approach e to the 1. Well, e to the ln, they cancel out. So this is just 1 plus x to the 1 over x power. And it is approaching e to the 1, which is e. So, and that's what we wanted to show. 1 plus x to the 1 over x is approaching e. A limit of 1 plus x to the 1 over x is e. So that actually shows that that's true. So I won't have you doing homework problem like this, but I wanted you to see that idea and get some good review of the limit definition of the derivative and see how we can bring derivatives in to help us compute limits. And we'll see more of these. They're called indeterminate forms. We'll see more of those later. Those are always fun.